Hello everyone, I am Shayok Kumar Dhar. Now I am going to solve a beautiful problem that came on CSIR net. It's basically based on linear algebra. Okay, so it has been told that let you denote the span of this set in real vector space of continuous functions from R to R. Consider the R vector space V. It is a vector space defined as follows, and W is defined like this. Okay, I have to find out the dimension of V and dimension of W. There are few options, four options about dimension of V and dimension of W. So basically I have to find out these two. Okay, so to approach this type of problem, it's a very easy problem. It has been told this one, so you have to recall few things. Just recall few things. I am writing it down here. Recall if dimension of V equals to n, this implies dimension of V star. V star means set of all vector space of all linear functionals from V to R. It's basically set of all linear functionals upon R V. Okay, its dimension is also n. Fine. And number two, you should know that if dimension, I am getting it number one and number two, dimension of V equals to n and W be a subspace of V with R linearly independent constraints, it implies that dimension of W equals to n minus. Okay, you should know these two things. Now I can approach to the problem easily. Okay, so first of all, take this set. Just check whether this set is linearly independent or not. First of all, in one method, you can easily check that any of these vectors, it's all vectors, any of these vectors can't be written as a linear combination of other two. So it is linearly independent, clearly. Or you might check by in this method also, by method of finding Wronskian, you can check it in this method, just like this, e to the power t, e to the power 2t, e to the power 3t. And to below this, I have to write its derivative. Its derivative is e to the power t, its derivative is 2e to the power t, sorry, 2e to the power 2t, 2 to the power 2t, and its derivative is 3 to the power 3t. Okay, and its derivative is also e to the power t. Now the derivative of this, it will be 4 e to the power 2t, and derivative of this, it will be 9 e to the power 3t. Fine. Now find its determinant. But how can you? Now from this column you take common e to the power t. Okay, you take common e to the power t. From this column you take common e to the power 2t. Okay, and from this column you take common e to the power 3t. Then what it will be? From first column I have taken common e to the power t, from the second column e to the power 2t, from the third column e to the power 3t. Correct? Then that my determinant will be looks like 1 1 1 1 2 4 1 3 9. Okay, clear? So what will be its determinant? What will be its determinant? Now if you check this one, this one will be e to the power 60, e to the power 60, and it will its determinant, you can easily find its determinant. Its determinant will be 2. So the whole thing is not equals to 0. Okay, and if the Wronskian of the vectors are not equals to 0, okay, then that means these vectors are linearly independent. Fine. So e1, e to the power t, e to the power 2t, and e to the power 3t. This set is linearly independent. You can also prove it or check it by this method. Okay, fine. So this set I am just erasing it because there's not enough space. So I have found out that this is linearly independent. Fine. So if this is linearly independent and this is your so what will be dimension of U? U is span of this set. So if this is linearly independent, then span of this set, dimension of its span will be 3. Correct. So dimension of U equals to 3. Fine. Now what is given by V? Look at this. My V is basically U star. It means dual of E. Is it not? It's basically the vector space of all linear functionals on U. Okay, and from this, from 1, what can I say? I say that dimension of V equals to dimension of U star, and dimension of U star is, if dimension of V is n, then dimension of V star is also n. Here dimension of U is 3, so dimension of U star is also 3. So my dimension of V becomes 3. Okay, so I have already found out dimension of V. Now I have to find out dimension of W. Okay, now look at this. There are only it is a subspace of V basically by its definition, and it has only one constraint. Okay, that f of e to the power 3t is 0. Only one constraint, and it's linearly independent constraint. Okay, so that's why dimension of W will be, dimension of V is 3, and what is number of linearly independent constants? 1. There are only one constants. Okay, so 3 minus 1, so it is 2. So my dimension of W is 2 and dimension of V is 3. So it's all done. Okay, so just using these two properties and few things, this is the dual. You have to identify that this is dual. So just using two things, I can easily solve this problem. Okay, so to watch more videos like this, do subscribe, like, share and comment.